Welcome guys in this new lecture of AI native or vector databases series. In previous lecture we saw what is the difference between traditional database and AI native database. In this lecture now we are going to code and see how vectors actually work. So for this we are going to start with installing sentence transformer. So sentence transformer is nothing but it's like a dictionary, and it will translate English into a 384 dimensional map. Now important thing is that all these things we are going to do in building our LLM model is absolutely free. We don't need to have any tokens, we don't need to pay anything. That's why we are going to use this sentence transformer, and we are going to use this collab. So let's install it. You will see that most of the things are already available in collab. The remaining things will get installed. So the second thing that we are going to use is, now we are going to use this sentence transformer, and we are going to use a mini language model. So let me just import these things from sentence transformer, import sentence transformer. So I can auto complete this. Okay, this is sentence. Okay, I need to put underscore here. Cool. So from sentence underscore transformer we are importing sentence transformer. Take care of the case sensitivity. And now I'll be also using numpy, so let me write import numpy as np. Okay, now we'll be running this. Now it's time to introduce our language model. So I'll be using a language model provided by Microsoft, and it's inside sentence transformer. Let me just again write this sentence transformer typo. Okay, so the language model that I'm going to use is called mini language model. It has 6 layered architecture, and its second version v2, but it's not derived from a version v1. It's actually just an updated v2 model only. The purpose is it's light, it's efficient for our work, and it's pocket dictionary, fast, free. Most important thing, it's free, it's efficient. It was created by Microsoft, and it is trained on approximately 1.5 billion sentences. So for our purpose it's the most efficient model. Okay, so now let me create one database consisting of few lines. I'm copy pasting it here. So I have written 1 2 3 4 5 sentences in form of list. This is going to be my traditional database. So this is nothing but my traditional database. I'll be using this database for my model. Okay, now the next thing that we are going to do is, again we know that machine understands numbers only, so we're going to encode our database, and that is known as vectors. So let me create a variable doc underscore vector, and now I'm going to encode using my LLM model. So model.encode, and I'm going to encode this document. So what is this doing? It is actually converting my document into numbers, that is vectors. Again, there can be a question that why 384 numbers? So imagine trying to describe a person, and if we only use 2 numbers, height and weight, we are not going to get much information. But say we are introducing eye color, hair length, favorite food, tone of voice, say 384 values, so we can get incredibly detailed portrait of that person. And this 384 is just doing, it's creating a numerical portrait of our sentence in a very detailed manner, so that no two different meanings either occupy the same spot. Okay, so now I have created one query here. Tell me about space and planets. So this is the query, input query, that I'll be going to search in my database. And again, like I have encoded my document, I'm going to encode the query also in form of vectors. So this is the actual use of vectors. We are converting our sentences, we are converting our non-numeric values into numeric values, that too in very detailed manner, so that again no two different meanings will occupy the same spot. And now again we have vector form of our database, we have vector form of our query. We'll do dot product, and what dot product will do, it will give direction. Say this is vector, so we have magnitude and direction. We are going to look for words which are pointing towards the same direction. More words are pointing towards the same direction, more positive values or more values pointing towards the same, then we are going to have more accurate result. Now let me check these auto completion things. Okay, now what I need is to have the best answer. I need to have the maximum value here. So I'll be using np.argmax, and I am going to check which is the best answer, which is the maximum value that I am going to get. That's it. And now let me print the things that I am going to display in the result. Okay, so first I need to print the query, so I'll be printing query here. Again, this is the input query that I'm going to need to check in the database. So this is my query, I'll be printing it also. Then I need to print the most important result, which is the best result that I got. Okay, and then I need to print the confidence score. So this confidence score is going to tell me how confident my model is in giving the best answer. So let me write here confidence score. Okay, so these are the things, and we have created our first vector database and demonstrating the use of vector database over traditional database. Now let's run this. Okay, so you can see several things have been downloaded here, and let's see the result. So the query was this thing. I am asking about a space and planet, and you can see the best match. The best match is this: the sun is a star and center of our solar system. The confidence score is pretty low, 0.38%. Let's analyze these things first. So you can see what is the output. I asked the AI about a space and planets, but if you look at my database list here, see clearly there is no word space, there is no word planet here. In traditional database, this would return 0 result. But because this is AI native, the system converted my question into a vector, a mathematical coordinate. And in the previous lecture, in the first lecture, we learned that AI native databases, they don't just look for labels, they look for meaning. So automatically it understood that sun, star, solar system, we are talking about a space and planet. Okay, so this is the most important difference between traditional database and AI databases. Talking about confidence score, it is quite low, 38%. But again, remember, we are taking the meaning. We are not exact matching everything. So 38% is there, but it is already giving 100% result here. So this is all about how to create a vector and how vector databases are different from traditional databases. That's it for this lecture, and we'll meet in the next lecture. Thank you.